We're at the University of Warwick and WMG to meet Pinky, the rescue robot built by the students.
Our task every year is to design a robot to traverse and map a rescue scenario. The major scenario is ideally for earthquakes, especially buildings that have collapsed. Every year, this is currently the 4th year that the project has been running. We're a group of 7 engineers and 4 computer scientists. So this is currently the 4th robot that we've actually built. But it's currently about Mark 3.5. Every year we enter the German Open for the Robocup Rescue competition. We won last year, so we're currently top in Europe, and we also were top in mobility. It's held every year in Magdeburg in Germany. One of our major things this year is we're going to be adding the Microsoft Kinect. The Kinect adds a lot of utility in towards its mapping capability, where it's able to scan a 3D room or area and provide quite accurate results for the price, which is really, compared to its competitors, is about 10 times less than what we'd usually use. Some of the equipment we previously used only gave us 2D planes of information. It might be slightly more, on that plane, it might be slightly more accurate, but that's not really what we really need for the competition. Rather, we wanted something where we could map in 3D in real time, and also at a low cost. Add to that, there was also the very large and active hobbyist community, which has sprung up since the release of the device last November. Well, in regards to how we do it, the actual Kinect gives out a plot of 3D vertices, which we're able to add to a mapping system. With the material, the stuff we've already built, we can then use it to actually tell the robot how to traverse the arena it's currently in. How the Kinect actually works is it sends out a field of IR beams which reflect off surfaces, and then it uses its own IR camera to measure how the shapes made by the IR beams, and from that we can create a depth image. This depth image allows us to perform edge detection on the objects in our field of view, and then from there we can determine whether an object is close to us, what the shape of the object, whether we can move around the object, and really what type of arena we're in.
Students on the 4-year MEng degree at Warwick take a group project in the 4th year, which is worth 25% of the total credit for that year and 10% of the credit for the whole degree. The intention is the project be multidisciplinary, and we have a team this year with a mix of students studying electronic engineering, systems engineering, manufacturing engineering and mechanical engineering. My background is systems engineering. My colleague Emma Rushforth has a background in automation and robotics. Well, in the 4th year group project we direct and we don't supervise, and we give the students a lot of freedom to make their own decisions about technology and planning and managing the project. So that the idea for the Kinect box, as with much of the other technologies that they've deployed, came solely from the students.